For me is being a son of two teachers is lecturing and making sure that the next generation has the right mindset, and also we challenge our mindset as they develop and grow. And I would like to bring in a very personal story in the beginning of this short presentation, is that I was back in architectural school, and the dormitory where all the architect students were living was right across the construction site. So when we had the classes on how you do foundation and the water insulation, I had a real-time view of how that is happening. So there was this big shopping mall being built, and after the load-bearing concrete structure was ready, the whole project stopped. And suddenly, my roommate got a job, an internship, and back then it was very rare to have paid internships for architects. I don't know if it's still the case, but back then it was the case. And then he needed to model the building that was being built across the dormitory. And we found out that the reason for this, and then for the drilling that was happening, is that the load-bearing concrete structure couldn't adopt all the ventilation shafts for the parking garage. Now, for a construction project, a half-a-year halt is super costly. But this was close to 20 years ago, and I would assume that we are in a far better position than 20 years ago. And I see many of the previous presenters made similar points. So with the context of the Nemetschek group, we dig out some studies to see that what is the current state in that, and 90% of the building projects are over budget or over time, which for an investment perspective makes it is a super risky investment. So that's lots of venture and funds entering the whole scene. So we have a big problem there overall on governing all of our projects, because clearly we are not in a position to be able to control the outcome of the projects. The second thing is that 40% of the CO2 emissions are governed by the building industry. And for me as an environmentalist, that's a social responsibility from my side. But it's very individual. So now governments are acting and requiring carbon life cycle analysis and all sorts of things, which is good to drive this. And the motivational bit is that on such a high number, to have a small impact is rather easy. So we can quickly gain things, and that's, I think, a super important task for all of us. And the next aspect in this whole is error and rebuilding, which is tying to my examples, is that once something is planned and designed, during construction you reveal errors that you need to revisit and then do it again. And that is just clear waste, which is super expensive to correct in the late phases. So that's why in all early BIM studies, this curve was there to push most of the decisions early in the design phase, so that later on we can have a far better outcome. But these errors also contribute to the waste, which if you combine with the CO2 impact, then you see that there are in fact easier ways to control what's going to be it. And of all of this, a trend that I think all of us working for various businesses see, that there is a lack of manpower. It's very hard to find the right qualified people to work with us, and with that contribute to the right quality and the outcomes. Now the economic aspect, which is very trivial for all of us, but is impacting our whole industry, is the side effects of the pandemic. What governments did as a preventive measure in an uncertain time, over-investing in certain things to make sure that we survive, but now we see all of the waves that was generated by pushing lots of funds into many of the industries. And also the supply chains got hooked up over the course of the last 3 years, and that removed many vendors even from the story. So now it is time to try to rebuild all of that. And it is combined with all the uncertainty around the world and inflation and all sorts of things. I just read in the news that inflation is getting better, for example, Hungary, but it's pretty scary, 25% inflation over the course of a year. So there are plenty of people who say that this is not a recession. There are plenty who say this is a recession. My conclusion, or our conclusion from the Graphisoft perspective, is that the next normal is volatility. So being prepared to embrace anything new is that the constant in the whole story. And to see stay optimistic in that. So what we can do? And I think that is the summary of 3 things. Collaborate, be more efficient in the collaboration, explore any new technologies, processes, means of driving your businesses so that you can deliver. Because by the end of the day, those companies, organizations who are deliver, who stay competitive, who are able to transform themselves in such times, they will be better set up for the future. So once the growth is coming back again heavily, then those companies will be able to ride that curve out of all of this. And from these 3 points today, my focus is collaboration, which was also partly covered by many of the presenters here. And just not to be biased towards the Graphisoft world, we work with an external company called Tech Clarity to have a survey and a research around it. What is the state of the collaboration? So how AEC players are collaborating nowadays? What is the current reality? And one of their key observations was that projects are becoming super complex, more and more complex by every day. And yesterday at the dinner we had conversation that there are many mandates that do BIM. Why to do BIM? What is BIM? What do you need to do? So there is lots of uncertainty why you want to think in complexity, and there drives value for all of you. But for me, a key learning from this is that if you just follow and execute your existing workflows, eventually you will fail because the complexity is constantly growing. The other angle of this whole story is that many players are thinking about breaking down the silos between all the disciplines that are involved in a construction or a design project. And some play with this idea, some actually started to do it, some failed in it, and in some companies it's an everyday they use. And that also contributes to the previous complexity, that suddenly you don't all only work in your silos, hand over the data and then out of here, and then you take care of the rest, but there is a shared responsibility on how we will make it work. And that very much ties to collaboration in my end. And to dig down, what are the key challenges that might make projects unsuccessful or would block you from achieving the objectives? And there are these first 3 that I would like to mention. One is poor communication. This came out from any survey, which should be very easy to do right communication, but we will see that it's not that easy. The second is managing material and product parameters. That more where processes and technology can help us, but clearly we have a problem. And the third, which I already mentioned, is the increased complexity. So I think if we are able to have a handle on all of these and have a development path, then we can far better influence the outcomes of all of this. And if we break further down the communication, and again, it's very similar insight to previous presenters, if we see the top 3 means of communication, we could be 200 years ago only doing that on paper. So the whole industry very much relies on very democratic tools instead of utilizing those things that drive efficiency and avoid people to doing things that are super manual. And that's where I will touch now the first time the human aspects of this, that in this labor shortage time, losing people's motivation because they need to do repetitive tasks is a very big problem. And this research, so I'm not going to share all of the details from this, but it's available on the Graphisoft website, so you can have a link there and see it's a very good study and very interesting. So we are here at collaboration, and then how we can improve our collaborative approaches. And if I try to break it down, there are 3 major areas for collaboration that we see that are essential. The first is across locations. Again, a very specific example from my professional life. When I started to work at Graphisoft, it was the time when we released our real-time teamwork solution. And it was the previous financial crisis, and many of our clients in Iceland just went out of business. There was 0 projects done in Iceland. But they started to work for Norwegian companies where the oil money kept things afloat. So it was clear that utilizing technology to go for a different business have to survive people in harder times. I mentioned across disciplines, and the third point is across systems. So information doesn't make sense or data that is logged in a silo. So you need to make sure that this flows between the stakeholders and as automatically as possible to remove the human barrier from the whole story. And I brought one case study. I should just mention the good-looking presentation, but there is a story inside. So another project while I was personally involved from the vendor perspective. So there is this Merdeka Tower in KL, Kuala Lumpur, in Malaysia. It was done by an Austrian client of ours, Fender Capabilities. It's a super complex project. It's like the second tallest building. My point is not to talk about the very project, but how you tackle very complex projects. And the challenge is very easy with any project like that, is that there are multiple stakeholders. So it's not only the project is huge, but there are multiple architects, structure engineers, building system designers, landscaping, urban planning. If the whole thing is connected to a metro line, you need to make sure that you can simulate the flow of people, how they exit the building, and how they enter the environment. So there is lots of stakeholders involved in the project, and then how you are able to communicate all of that. And once you were able to communicate, how that information gets back to your model, the model that is relevant to you, so that you can follow up all the changes that are happening. And in this particular case, the client was using Graphisoft solutions to do all of those, and there was a high-level automation that they put in, either also doing custom developments on top of the available technologies like object creation, API connections, scripting, and all sorts of things, but also with working with the external consultants. And for that, and now it's the second time I'm mentioning the human aspects of the whole. Craig and the team in Melbourne, they are a super collaborative firm. And for example, as a leader at Graphisoft, now for us it's a very heavy focus to create an environment for our colleagues that they will come to Graphisoft, work at Graphisoft, and also through the culture they will stay there and stay motivated. And I think Craig and the team does that very well, and their internal atmosphere was very, very well visible also with their contractors and those people who they work with externally, and their full trust workflow then could easily adopt the technologies that were available. So it's always a mixture of people and the processes and the technology. I just want to make sure to highlight the importance of the people aspects. And then on the technology stack, when you have your collaborative environment where you can invite your consultants, contributors to work, no matter the location where they are. So you can hire a guy in the UK to do a certain things for you. That's very essential. One thing that the industry haven't solved, and from my perspective is relevant, is time zones. So you can hire somebody in the US, but if they are West Coast, then you cannot really work in human times with them. So that's a challenge we can overcome. So we could see that in a setting, our clients could easily work. But as the complexity is growing, we need to always seek ways to work better. And that's where multidisciplinary design comes in, so that how you can bring those stakeholders closer together so that you don't need to replicate the same work. And one thing that we did over the last course of 3 years is focusing with many other software brands on the structural architectural workflows. So what is the handover point from a building design, which is described in 3D, filled up with information, and what is the handover point for the analysis, the structural analysis? And there a key learning is why architecture in a sense is very general globally. The structural calculations are super local and relevant to the geography where the project is actually. So it's not even about where the client is, where the project is. So our Japanese clients, for example, when they do any building design, seismic planning is #1 priority because that's part of their everyday life. For us in Budapest, there are some easy rules that even I could study at architecture school that I can apply, but it's a completely different things. So we need to make sure that once you have this data handover point, then you can hand over the relevant data for your structural consultant. And in a sense, with many brands, we created the structural analytical format standard, which describes that part of the geometry loads the structural analytical model that you want to hand over for the calculation. So that prior to that, any modeling of activities, any extending the geometry with the parameters can be done together in a shared system. So just explaining that workflow on a diagram from the collaboration perspective. So typically if there's any design task, then any collaborator would proceed their own path. So I have my information from the project, I know what my task is, so I will develop that bit of the project. And my collaborator will do the very same. And this is where it comes the project coordination, so that we avoid that we are working from different data sets. Sometimes we stop and then we have a collaboration meeting to make sure that the whole project goes into one direction. Now, an upside of that, obviously, is that there is a shared model being eventually developed. The downside is that any such coordination will result in data loss in the sense that you identify errors that you will need to carve out, and some people are working on assumptions that are no longer true in the project because that column is already moved by, for example, the structure consultant, and the architect is still designing the bathroom layout around it. So embedded in the system, there is waste of production. So how we can improve that? And one way to improve that is to increase the frequency between the coordination times, and that can be done bi-weekly, weekly, but as you increase that frequency, at the end there's a limit because you would do just only coordination. So embedded into the workflow, there is a given limitation of efficiency, because the more repetitive you are, the less you spend also with design, less assumptions, but more time for collaboration. And this is what we call the federated approach. The other way how we could improve is the full trust, all trust workflow. And there everybody would see anyone's work so that they can right away identify, change things, and they can act upon those. So overall, the outcome would be that you can proceed faster. But the downside of that is that proceeding faster, then the responsibility is not becoming clear. So for any of such setting, even the previous ones, you want to make sure that you have the quality control checkpoints. So before you submit data, you have a governance that you do checks, so that to make sure that something that happens is in your right intent. And there is a whole trade and processes of how to do checking on models. And in integrated design, that's something that becomes even more important. And it becomes even more important of the sake that there is a full trust, everybody is doing something, and you want to make sure that nobody gets sued at the end. And for that, you need to build up your right processes. And it's not only about specialist software like SolidWorks, there are plenty of others. For me, it's like a state of mind, and our software engineering teams do that by nature, that as you build a code, you right away start building the code that will test it, and you involve your tester in use cases, and those use cases can reveal you what to test so that being control of the outcome. So it's very important to be in a position to be able to check and control the outcome of your project. So if I do a little bit of comparison of federated and integrated design, then we can see that federated is that there are individual black boxes of collaborators, and they have their own responsibilities, while in integrated, everybody works in the same things. Federated involves cycles and iterations. Integrated design is like a real-time collaboration. The governance in federated is in these checkpoints when you do the coordination meetings, which so many of our clients complain about those meetings. 15 people in an airless room spending one day, it's very tiring. But obviously for integrated site, you need to build up the continuous governance on all of those. And from the approach, it's clear that if you go on a federated approach, any data that you pull in, you want to make sure that goes through the federated route. And in integrated design, actually, you can seamlessly embed that data because you have built up the governance check. And it seems now that everybody talks about AI. Obviously, that's something that keeps the whole industry busy. Recently, we had a meeting with Microsoft, and their example was that since Windows 95, that's the second biggest thing in Microsoft's life, and they are betting huge money into it. So it's very clear that now, I don't know if you are familiar with the Gartner hype curve of any technologies. We are, I think, at the top of the AI hype. Now we are trying to identify the real use cases of it, and then we will see all the downsides of it. But from this approach perspective, my point is that how you can prepare to embrace that whole story, and how that story evolves, that's going to go on a separate path. But just a highlight of what potentials AI could have for the building industry. So how AI works is that you have a set of inputs, it will generate a set of outputs. You can even define these, and through teaching the algorithm, machine learning, deep learning, then it will become very good in coming up with prediction how things should be. And the key in this whole thing is prediction. So it's never gonna be certain. So your quality control and checking will be always required. So that's why I'm not very afraid that it will take away human work. It will not take away human work. It will give us tools where we can be very efficient in certain parts of the life of, in this case, building design. So where AI is very good is recognizing things. And any architecture design work is full of point geometry patterns. So it's very good that you can read, if this happens, then that's what I'm looking for. If another time it sees the very same thing, then it can interpret it, yes, maybe I need to do there a label that you already did on previous projects. It's very good in converting things. We see all of these mid-journey arts where from a base image it can start and give you lots of context and extra detail in your drawing. It's very good in predicting things on previous patterns that you thought. So whenever, for example, in Google Maps, you just set a navigation, it's super precise at the end. Why? Because it feeds on historical data of traffic, what is happening in the given city at the given hours, and every year there is a celebration that impacts that day's traffic. So that's why these systems are super good on predicting what's going to happen, but they are never bulletproof. And the most exciting thing for building design is actually generating additional content. Like code, we played around building GDL code or Python code, or even our programmers use various tools to generate code that they then adjust and check to be able to use. The whole design works lots of repetitive elements. So if you imagine a day as a designer, like architecture designer, then you will realize that a very small bit is creative, and the other is modeling, making sure that drawings have the content that is legally required, putting them on sheets, publishing outputs, discussing those outputs, coming back with the changes, and doing all of this repetitively again. So that's where I think there are huge potential for AI. And also when it comes to a level that it can give us annotations, and the ultimate goal, which everybody talks about, nobody does it very well, is to generate your buildings through elements that can be part of the up to the model. So how this relates to our whole story? It is, I think, a new source in that conversation, because federated and integrated approach will always stay side by side, because with some collaborators you will want to make sure you're embedding them with the design. With some you need to make sure that it's federated, so it's never going to be black and white, both required. Where you have control is that where is that handover point, with which stakeholder, where you do the handover. And in that story, I think that handover is going to be greatly influenced by where we put AI in the story, because you want to make sure that it feds data into a very visible, transparent system. And also, if you use it to teach your algorithm, it is building on data that is available for it. So doing it silos, it's less good than doing it in a more complex ways. So I think for us, a learning could be is that while there are these two approaches which will always live together well, we already can pre-build our processing. So in a couple of years, when this reaches production, our workflows, processes, quality control, and all sorts of things are in a state that it is easy to embrace any of those new technologies. So that was the train of thoughts that I wanted to share with you. And I will be here on the event, and if you have any questions or ideas, do come to me and